All right, we have already talked about measures of central tendency, measures of center, and now we're going to talk about measures of dispersion. Those go together. The measures of center talk about where the middle of the data is, and measures of dispersion are going to talk about how wide or spread out around the data that is. So what I have here are two histograms, and both of these histograms have the exact same center. This is a 6, and this is also a 6. So the center of these two distributions is exactly the same. They're both 6, but it's very obvious visually that they're different than each other. This one has a much wider spread of values. Its values start at 1 and go all the way up to 11. And even here in the middle between like 3 and 9, there's quite a tall bars that are encompassing those values. So this dispersion, the spread of the data around the center point is much bigger than the dispersion of this, which only goes from 4 to 8. And so the bulk of the data here is really between 5 and 7. So it's a very different picture, even though they both have the same center. So that's why it's important that we talk about the dispersion or the spread of our data, that along with the center, they do go hand in hand, and they do explain a much clearer picture of your data. So the first one we're going to talk about is in terms of the median. And again, these measures of spread or dispersion are linked specifically to the measure of center. So with median, we're going to use a couple different measures of spread, but only those. We aren't going to mix and match here. So with median, we can talk about the range. That's one of them, and that's a pretty simple calculation. It's literally the max minus the min. So my data is kind of covered up here by the camera, but these are shoe sizes from one of the IB classes that we collected data on. So the max minus the min is literally the max. Biggest shoe was 14, the smallest shoe size was 6, and so if I wanted to calculate that range, I would subtract those. And I do want to point out, it's very important that the range is this single number, 8, and it does have units. It's 8 sizes. I don't know what the unit is for your shoe size, but it's that single number. If you wrote 14 minus 6 as the range, or 6-14, that would not be marked correct. They would expect you to actually do this subtraction of max minus min. This is actually a subtraction sign. It's not just giving you a dash, giving you the high-low. You have to subtract them. So the spread or the range of the data for your shoe sizes was 8. The other measure that goes with median is the IQR, which is called an acronym for the interquartile range. So the I comes from inter, the Q from quartile, and R from range. So we are calculating a range, which is again a difference between two values, and we're doing it between the interquartiles, and the interquartiles are the third quartile and the first quartile. So which really encompasses the middle 50% of your data. If you break the first quarter and then the third quarter, 50% of your data happens to exist in between those two quartiles. And so I'm really figuring out how wide or how spread out is that middle 50%, because that's really the clustered part around the center or the median. And so to do that, we would have to find a couple of values, and that would be the quartile 3 and quartile 1. And again, quartile 3 is kind of covered up here. I'm not sure you can see it. I can see it, but I don't know if you can. So quartile 1 is the median of the bottom half of the data. So it's literally the middle of the bottom 50%, and quartile 3 is the median of the top half. So if you can't read this, this just says of the top half of data. So I guess I could write that here, top half. So if you needed to calculate the median, the IQR, you would first have to find the median and then find each quartile, which is in essence calculating additional medians. So we're going to do this the long hand way, and I'm going to change some colors here as I go. All right, so if I want to find the median, I literally, if I do it the old-fashioned way, I'm going to cross these out as I go, one from each side. And I'm making sure I don't miss any. It is also important to know that these must be in numerical order. They have to be in order for you to be able to calculate the median. If they're not in order, That's your first job, is to put your data in order, and then you can do it. So it looks like this has two values that fall in the middle, and so the median is the average of those two, and luckily for us, it's super easy to average 9 and 9, so the median would be 9. So now the reason I needed to find the median is now if I want to calculate quartile 3 and then quartile 1, this is the median of this top half of the data. So now I have to find where is the middle piece just in this 50%. So I'm going to use a different color. So I'm going to cross off one at a time from each side and try not to mess this up. This is very high-tech mathematical calculation. And so there we go. Not quite as easy, but the quartile 3 would be the median, which again, when I have two data values, I have to average them. And so the average of 10 and 11 is 10.5. So that would be quartile 3. And then if I want to find quartile 1, I would do the same thing down here. So I'm going to cross off from left to right and again track down where that middle value would fall. And it looks like it again, quartile 1 is going to capture 7 and 8 is I'd average those, and fortunately that's another easy average to do. So quartile 1 is 7.5. So the median would be the difference between those. So 10.5 minus 7.5. So again, this actual subtraction is important. So the interquartile range is 3 sizes. So the interquartile range is between 7.5 and 10.5. And again, the quartiles just kind of break this into quarters. So that's like your first quarter, that's like halftime, this was like the third quarter. And so each of these, you'll notice, has the same number of data values in it. And that's what it means by quarters. You have it's collecting how much data is in there, and then it tells you the marker or the location for the actual position of quartile 3, median, and quartile 1. So next up is a graph that goes with the quartiles and the median. It's actually called a box plot, and it graphs the 5-number summary. And the 5-number summary is the minimum value, first quartile, the median, the third quartile, and the max. And we already have calculated these guys right here. We just did that on a slide a minute ago. The min is really easy because it's your smallest value. And the max is also pretty easy because it's your biggest value. And we use those in calculating the range. So it's really just putting those 5 numbers together to create the 5-number summary and then a graphical representation of those. So this is the 5-number summary. And so if I want to make a box plot, first off, I'm going to put a box around these values right here. So quartile 1 would be 7.5. And then this is actually pretty balanced. It looks like it's 1.5 to 9, and then another 1.5 to 10.5. So you do want these to be like properly spaced in terms of how far apart they are. So this would be 7.5, this would be 10.5. And so the box part of your 5-number summary is the box around the quartiles with a little dash through the middle for the median, and the median was 9. And then you draw what used to be called a whisker up to the max. And the max is, again, this is only 1.5. And this looks like it's closer to 3.5. So it really needs to be about twice as long as this distance right here, because you want these to be properly scaled. But this is just a half. So the min is really just hardly below that quartile. Oh, actually it's 1.5. So it would be about the same length as this. So there we go. That would be our box plot. You would label it shoe sizes, IB class. You could put you don't have to put your scale on here. You could put a scale down here and be like 6. This is 9. This is 14. And it should basically be numerically correct. But you can also do this in the calculator. So I do want to show you that very quickly. So if you pull up your calculator, actually I'm going to have you pause very quickly, and you're going to want to put this data in your calculator into list 1. So do that really quickly. All right, that is done because you paused it. So again, if you need a reminder, you hit stat and you hit edit, and you would put your data into list 1. Now I'm going to show you how to clear a list before we move on so that you don't accidentally delete a list. Like this list 3, I'm not using this anymore. So if I come over to list 3 and I move the cursor to the very top where it actually says list 3, and I don't want this data in here anymore, I hit the clear button and then I hit enter, and the data is gone from that list and I can re-enter data. So I've put our shoe sizes in list 1, and if I want to make a graph of this, I come up here, just like we did a graph for the histogram. I'm going to hit second y equals, which is our stat plot button, and I'm going to hit enter. And I'm going to turn the plot on. And notice here are our graph options. You have Boxplots, and I'm going to talk the difference between these two. At this point, it doesn't really matter which one you use. I'm going to use the second one for now, and I'll talk to you about why in a minute, a little bit later, but I'm going to use that Boxplot. It looks just like a box plot. I have my data in list 1, and I do not have a frequency list. I put my data in individually. So now I can hit zoom 9 or zoom stat, and it will give you a box plot. And if you want to know what the values are, you would hit the trace button, and then you can move from value to value, and it tells you right here you're in quartile 3 what the value is, what the max is, and you can walk all through your 5 numbers in your 5-number summary. I do want to point out this is mine is extremely close to this, not just in color, but also in the way I spaced everything out. So that's pretty amazing. And again, there it is in the printout. I copied that off. So there you go. That's a median and a box plot. And the two measures of spread that go with the median, again, are your range and your interquartile range, or your IQR. And a box plot describes that as well. And you can also notice the shape of this. This is skewed to the right. This is like a long tail. If this were perfectly symmetrical, this whisker on the left would be about the same as the whisker on the right. The middle 50% is very symmetrical. That median is dead center in your quartiles. So that's pretty nice right there. But this would be skewed a little bit to the right. So just like if you look at a histogram, if this is skewed to the right, I would want to use the median as a measure of center. And now I would also either using the IQR or the range for the measure of spread. So we do need to also calculate if there are any outliers. And again, an outlier would be any piece of data that is significantly removed from the general overall pattern, or if there's a big gap. If you're looking at a histogram and there's a big gap or a really long pull. Just because you're skewed doesn't mean you have outliers. So there is a mathematical calculation to determine if you have an outlier, and it is a really uniquely named 1.5 times the IQR rule. So what you want to do is figure out what the IQR is, multiply the IQR times 1.5. And so what you're really saying is, look, I know where the middle 50% of the data is, and I'm only willing to go out from both of my quartiles about 1.5 times that distance. Anything beyond that would be considered an extreme value. So I would recommend doing that. So we have to find our quartiles and our IQRs, and then add and subtract to the quartile, each of those quartiles. So for us, that would be our interquartile range was 3 for this data. So if I multiply that by 1.5, I get 4.5. And then I would then add that 4.5 to the third quartile and subtract it from the first quartile, and that would get me my values that I would have to stop at. Now notice that 15, anything above 15 would be an outlier. Well, I don't have anything above 15, so this is not an outlier. And any shoe size below 3 would be an outlier. This is not below 3. So this set of data, even though it's skewed, has no outliers. So this is where I usually draw a fence over here on the right. Boom, and I draw a fence here. And I don't have anything outside of my fences, so nothing is beyond these two values. So there is no outlier. So that's going to end this first video, and we will continue with our second video on the mean.